Okay, hello everyone. I just want to give you a quick review of exam one and show you how easy the exam one was. So the question number one is you have a linear transformation, and here you have a matrix representation of t, and then you are asked for what kind of value of k t is not onto. Okay, the typical way to solve this question is that you could easily find determinant of a, and then because this is just 3 by 3 matrix, you could just you could and we want this t um, not to be one to one, so therefore it's enough to show that for what kind of value of a determine what kind of value of k determinant of a is equal to 0. Therefore you can easily compute determinant and then check it. But there is a much easier way to check it. So for example, if you take k, just take k to be 1, therefore you have this matrix 1 2 3 2 1 3, and then 4 5 and then 9. And here you can easily check that if you add this column to this column, you can get this column. So this shows that your columns are linearly independent. Therefore 1 is definitely one of your answer. Therefore you can easily omit b, you can easily omit d. So now it remains to show that whether k is equal to 7 or k is equal to negative 7 is your answer. To do that, you can easily just take k to be, for example, 7. Then what you have here is 1, 2, 3, 2, and then 7, and then 3, and then here you have 4, 5, and here you have 15. And here if you look pretty closely, if you multiply this column by 5 and then multiply this column by negative 1, you can easily get this column. Isn't that true? So 4 times 5, 20, minus 5, 15, this one 10, minus 7, 3, and then this one 5 minus 2 is 3. So therefore, as you see, the columns of A is linearly independent, and it means that t is not 1 to 1. Therefore the answer is C, and then you can check it even without the computing the determinant. Less than 2 minutes. That's why during the class I'm always saying that this MCQ question, those are kind of double-edged sword. Sometimes you can boost your score by that because the correct answer is among those options here, and sometimes if you naively make even a simple mistake, you can lose a point. So the question, the second question is that consider the following 3 vectors in R4, and then you are asked for which value of h. So this set of vectors, this set of vectors is linearly dependent. Here is linearly dependent. Linearly dependent means that you can write it as a linear combination of each other. So this question is also pretty straightforward. There are different methods you can do that, but one of the simplest method is that, here although those vectors in R are 4, but those 0 here doesn't really we don't care about those things. So therefore you can just ignore those 0 here on the bottom for a sec, and then just compute the determinant of this matrix 1h0 0 0 1h, and then h squared 0 1. Determinant of this matrix is equal to what? Is equal to, okay, let's expand it around for example, let's say the first row. Therefore here you have 1 times what? Times h, because you want to omit this and this, and then plus h squared times negative 1, right? Times times negative 1 to the power of 4, which is 1. Therefore I don't write it, times determinant of this matrix here, which is h squared. So therefore determinant of this matrix is going to be 1 plus h to the 4th. So we want this set to be linearly dependent. So this means that the determinant of this matrix V1, V2, V3 should be 0. So therefore, this means that 1 plus h to the power 4 should be 0. This means that h to the power 4 is equal to -1, which is a contradiction. Why is the contradiction? Because this is a positive number always, but this is negative. Therefore, the answer is going to be E. So there is also another solution. You can easily check that out. For example, you can check here. You can easily check if you take h to be 0. If you take h to be 0, okay, here is crystal clear that those vectors v1, v2, v3, those vectors are linearly independent. Therefore, this one and this one cannot be the solution. You can also try to take h to be -1, and you can see that if you take h to be -1, if you take h to be -1 here, and then here if you take -1, so you have +1. You can see that those also cannot be linearly independent for 1 also as well. Therefore, this is not a solution. Therefore, I'm giving you 2 methods to check that, to help you to find the correct answer. The other question is about this kind of a composition of 2 linear transformation. One of them is reflection. Yes, one of them is reflection along the line y is equal to x. So, and then you should keep in mind that if you have this, if you have the line y is equal to x, so if you have point, let's say E1, which is equal to 1 and 0, if you reflect it here, then you will find a point here, right, E2. Therefore, reflection is this kind of E2 is what? E2 is 0 and 1. Therefore, reflection is kind of changing the coordinates, right? So, and this matrix, if you check this matrix, right, if you check this matrix here, and multiply by x and y, you will see that this gives you y and x, right? So it's exactly this matrix here gives you reflection around the y is equal to x. Therefore, I have here 0, 1, 1, 0. Okay, and the other one is kind of, and then you rotate. So we know that for rotation, the formula rotation around alpha is always this matrix, cosine alpha here, minus sine of alpha, and then sine of alpha. Okay, for this one, because alpha is equal to pi over 4 here, therefore you have root 2 over 2, root 2 over 2, here negative root 2 over 2, and here you also have root 2 over 2. Okay, so now, okay, you have this transformation, you have this transformation. The typical confusion here is that you don't know you should multiply this to this from, or you should multiply this one to this one, or from which side. But here is the actual trick, because you are doing first reflection and then rotation. Therefore, you should multiply first. You should have this one first, and second this rotation here. This one 2, -2, and then 2 over 2, and then 2 over 2. So, and then if you just multiply this matrix to this matrix, if you multiply this to this, so you have negative root 2 over 2, and then here you have you have positive root 2 over 2. I think I don't need to obtain the rest of them, because this is not, this is not, this is, and then this is not, and then this is not. Therefore, the answer is C. I don't have to compute the rest of them. That's it. So you see, this is also a pretty straightforward question. So let's go to the question number 4. Question number 4, you have 3 vectors in R3. Which of the following statement is true? This kind of question is kind of conceptual question. So the part A is written that every vector in R3 belongs to the span of UVW. So it depends whether those vectors here form a linearly independent set or not. Therefore, you can easily compute the determinant of the matrix coming from the columns of this U and V, right? Here 0, negative 1, 1, and then 1, 0, negative 1. And if you compute this determinant, you can easily check that, okay, let's compute the determinant. It's going to be negative 1, and then this time there's negative 1 times 1 plus okay, I'm expanding around the first row, and then 1, and then okay, if I have 1, then I have 1, therefore it's gonna be 0. Okay, determinant is 0. When determinant is 0, therefore this means that the columns are not linearly independent, and therefore the span of those things cannot be entire R3, because one of them can be linearly can be a linear combination of the other one. So therefore A is not the solution. 0 does not belong to the span of this, so I should remind you a span of U, V, and W. This is basically means that what it means. It means that the set of all linear combinations, right? It means that all alpha U plus beta V plus gamma W, such that those are just scalars, right, from R, right? So now one can easily say that I can write 0 as like 0 scalar product U, right? Plus 0 scalar product V plus 0 scalar product W, right? I can write it. Therefore 0 is always in a span, therefore, and then here it says that it does not, therefore this is not the solution. So so far we check 1 and 2, so we can okay, here we can check this one, a span, because we already write the definition of a span. So I need the definition of a span here again. So part D says that a span of U and V contains U, V, W, and 0, and contains no other vector, which is not correct, because a span can be, for example, have, for example, a vector 2v, or for example 2v plus 3v, or any linear combination of those vectors. Therefore this is also not correct. Therefore here you basically left with two options, C and E, and then you already, because the determinant is 0, you can easily check that those are linearly independent. It means that you can produce each of them based on the other. Therefore, the answer is D. So, but if you still want to really check C is not the correct answer, you can just check that, okay, suppose that, let's check whether you can write this one, the vector 1, 1, 1, as a linear combination of U and V, right? So therefore here you have this, right? Negative 1, 1, 0, plus beta, for example, 0, negative 1, 1, plus gamma, 1, 0, negative 1. So if you just clear things here, so you can see that 1 is equal to negative alpha plus gamma, and then here you can see that 1 is equal to what? Alpha minus beta, and the last one, 1 is equal to beta minus gamma. So now, for example, you can easily add this one and this one, add them together. What you have is 2 is equal to gamma minus beta. But on the other hand, here you have beta minus gamma is equal to 1. If you add them up, what you have is 3 is equal to what? This and this cancel out, this and this cancel out, 3 is equal to 0. Therefore, this is a contradiction. The contradiction comes from the assumption that I assume that I can write this based on the linear combination of those things. Therefore, this is also not the correct answer that we already know. The other question is about the determinant. We do some row operation or column operation on this matrix, and then we get this matrix, and then we want to check what's the determinant of matrix. If you look at this matrix closely, you can easily check that you can easily check that here, the columns here, A, B, C, and then here you have A, B, C here. It means that there is kind of a transpose of your matrix, right? And then the good news is that we know that the determinant of A is equal to determinant of A transpose, right? Therefore, there is no, if we transpose a matrix, there is no effect on our determinant. But you can check that here. If you transpose, then you have E, D, E, F. But here, look, but here you have B, H, E. So it means that they transpose and then they change two columns. Therefore, this matrix is basically changing column, transpose. Then they exchange two columns, right? Two columns, and then they multiply. Okay, they multiply by 3. They multiply by 3 this column here. Okay, therefore the determinant will be multiply. They also multiply by 4 here. Okay, they multiply by 4 here. Okay, and they also multiply by 3 here, therefore they multiply by 3 here. So they also add it seems that they add this one to this one, which there is no impact on it. So therefore this is all impact. So if you exchange two columns, you have -1 here. So therefore the determinant of this matrix, let's call this one B. The determinant of B is basically -1 times 3 times 4 times 3 times determinant of A. Determinant of A is 1/3. Therefore this one cancel out. Therefore you have -12. Therefore the answer of this question is B. If you didn't like my solution, that's okay. There is an alternative solution. You can easily start with this matrix, right? Start with this matrix B, then try to do all this raw operation with different stage, and then get this matrix, and then see what are the changes, right? The second question is about the inverse of matrices, right? As you see here, you are asked for the inverse of this matrix times this vector, but you don't have to compute everything. You are only asked for x2. So therefore, if you consider, for example, the inverse of your matrix is like b1, b1, 2, b1, 3, b2, 2, 1, b2, 2, and b2, 3, and then here b3, 1, b3, 2, b3, 3. Okay, you want to multiply this to this 0, 6, 0. So because you want to obtain x1, x2, you want to obtain what? You want to obtain x2. Therefore, x2 is basically the multiplication of this row to this column, which is basically what? Which is x2 then is equal to 0 b2, 1 plus 6 times b2, 2 plus 0 times b2, 3. Therefore, we don't mind what b2, 1 and b2, 3, we don't mind what they are. So therefore, we only have to compute 6 times b2, 2. And we know that b22, this means that 6 times. Okay, therefore we should compute the b22 in this inverse matrices. As you know, so the A inverse is equal to 1/determinant of A adjoint of A, and then here, what is the determinant of A? Determinant of A, you can, because you have 2, 0 here, is better to expand it about the first column. Therefore, determinant of A is equal to 1 times C11, and then this is 1 times C11. It means that determinant of this matrix, which is 2, and then determinant is 2. Okay, good. So obtain determinant is 2. Therefore, so x2, okay, here x2 was equal to 6 times 1 over determinant of A, which was 2, times now times I have to compute C22 because B22 is equal to 1 over determinant of A, C22. So C22 means okay, let's compute this one, just this, and then the determinant of this is going to be 1, right? The determinant of is 1 of 1, then 6 times 1/2 is going to be 3. Therefore, the answer is A. That's it. You don't have to compute the entire of this matrix. You basically you only have to compute one of the entry of the inverse matrix. So the other one is this actually conceptual MCQ. So let's start with the first one. For any vector v in R5, a span has infinitely many elements, which is not correct. Why? Because here it says that for any. So if, for example, I take v to be 0, therefore a span of v is basically equal to alpha v, I mean linear combination of alpha, because it's just one vector, therefore I just write alpha v, such that alpha is a scalar. But if alpha is 0, therefore I always have alpha 0, while alpha can be everything. But the point is that alpha 0 is 0 always. Therefore, this set is always 0. Therefore, because we are looking for a statement which is always true, therefore this is not the answer. For this one, you can easily check that this is a matrix which is kind of a triangular matrix, and we know that for triangular matrices, regardless of the size of matrix, you can easily multiply the elements on the main diagonal and then find the determinant. Therefore, determinant of this matrix is basically t times t squared times t cubed times blah 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 times t to the 2026. Nice number. We are already in 2026. But if you multiply all of them, what you have is basically 1 plus 2 plus 3 plus blah 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 plus 2 2026, and this is not equal to 26 factorial, right? Therefore, this is also not true. So part C, the transformation T from R3 given by this is linear. Is it linear or not? So you should remember this remark that if T is a linear transformation, then T of 0 is always 0. Now, if you just plug in 0, 0, 0 here, what you have here is 0, 3, 0. So, okay, T of 0 is not 0, right? This means that 0 is not preserved under this T. Therefore, we know that all the linear transformation preserve the origin. So, therefore, this is not linear. This is not true. So, okay, now you left with D and E. You can check E easily. So, you have 11 vectors in R10. So, we know that the dimension of R10 is equal to 10, right? And we had a lemma that if you have a vector with, for example, such that the number of vectors is strictly bigger than the dimension, then the set must be linearly dependent, not independent, right? So therefore, this is basically this part independent, makes this statement actually incorrect. So therefore, we just have this one. Therefore, the correct answer is this. But if you want to check this statement is also true. So we know that determinant of A can be written that at determinant of A times determinant of A. So therefore, basically what you have is determinant of A squared. So therefore, the question is that if you take, for example, determinant of a to be x, like, because determinant is a number, you can just take it x. Therefore, you have this expression, you have this equation, x squared minus 4x plus 5 is equal to 0. Now the question is that whether this equation has a solution or not, so has a root or not. So you can easily compute delta. Delta is 16 minus 4 times 5. Sorry, here can easily check that. Delta is equal to 16 minus 4 AC. A is 1 and then C is 5. Therefore, it is going to be negative 4, which is strictly less than 0. Therefore, this equation doesn't have solution. Therefore, there is no square matrix A such that this equation is true. Therefore, because this statement is correct and we are looking for the correct statement. So we are done basically we are done with MCQ question. Let's move on and then go to the free response questions. For free response questions, so okay, here you are asked to find the echelon, to find the row echelon form of the augmented matrix. Okay, let's just form the augmented matrix here. Augmented matrix here is 1, 2, 1, the coefficients of x1. And then here you have 1a2 coefficient of x2, coefficients of x3 is 1, 5, a plus 1, and then augmented part is 3, 7, 4. So the first step, let's make this element and this element 0. Okay, let's make it 0. Therefore, what I do is just multiply first row by -2 and then add it to the second. Therefore, my first row is 1, 1, 1. Okay, and here is 3. So if I multiply this one, so here, therefore, I have 0. Here I have a minus 2. Here I have 3, and here I have 1. Is that correct? Yes, and then I want to make this one 0. Therefore, I multiply row 1 by -1 and add it to this one. Therefore, here I have 0. Here I have 1. Here I have a, and here I have 1. Okay, so far so good. It's very nice. So okay, now what I want to do actually here in this next step to make the computation a bit easier, to avoid any because now I want to make this one 0 and then this one 0. I want to just change these rows 1, 1, 1, 3. So I want to just change them like that, because I can change one row here with this row here. So with this one here, okay, let's change it so there is no effect on or the solution. So therefore here I have what? I have 0. I have 0, 1, 0, 1, a 1, and here I have 0, a minus 2, and then 3, and then 1. Okay, now go ahead. Now I want to make this one 0 and then this one 0. Okay, now it's easy because 1, 1, 1, and then here 3. So to do that, you can just multiply row 1 by -1, add it to second row. Here I have 0, 0, and then here I have a minus 1, and then here I have, if I multiply this one by -1, I have -3 to 1 is -2, I guess. So now I want to make this one 0, therefore multiply to 2 minus a, this one, and then add it to this. Therefore, you can easily make this one 0. Therefore, here you have 0, here you have 0, and here you have a times 2 minus a plus 3. Okay, good. And then again multiply this by 2 minus a and then add it to 1. Therefore 2 minus a times 1, which is 1, plus 1. Okay, therefore this is going to be your echelon form of the augmented matrix. Okay, let's clean here a bit. So here you have 2a minus a squared plus 3, and then here basically what you have is 3 minus a, right? So You are done with first part. Then second part, for which values does this system has infinitely number of solution? Infinitely number solution, it means that you have to have a free variable. So free variables, it means that you should probably have the 0 0 everywhere in this last row, right? In last row here should have 0 0 everywhere. So therefore here you can see that the roots of this coefficient is one is a is equal to 3 and a is equal to -1. Therefore if you take a to be 3, here you have 0, and then here also you have 0. Therefore in last row you have something like that, 0 0 0 and then 0, and then this gives you a free variable. When you have free variable, therefore you have infinitely many solution. So therefore the answer of this part is equal to 3. So the other one is for which values or value of a does the system have no solution? For this one, okay, this means that you have to have situation like this, 0 0 0 and then something here which is not 0, right? Okay, to do that, if you take a to be -1, then here is 0 0 0, and then here you have basically non-zero, right? Here basically what you have in last row, you have 0 0 0, and if you have -1 here you have 4, right? So and when you end up with such situation like that, so this means that x1 0x1 plus this means that what? This means that 0x1 plus 0x2 plus 0x3 is equal to 4. This means that 0 is equal to 4, which is contradiction. Then that's why you don't have solution. So question number 9, in fact, you are asked to find the reduce row echelon form of this matrix. Okay, here you should be able to remember the difference between reduced row echelon and row echelon. So first of all, because all of them, I can divide all the entries on the first row by 2. Therefore, let's do it like this. Okay, let's do it here. Why not? So let's divide each entry of first row by 2. Therefore, here I have 1. Here I have 2. Here I have 2. Here I have 2. Here I have 3. Here I have 4, and then this one is 0. Now this is 0. Fortunately, I don't have to do anything. So let's make this element 0. To make this element 0, you should just multiply row 1 by -1. So okay, let's put this one here, 0 0 no 1 2, sorry, 1 2. Okay, let's multiply row 1 by -1 and then add it to the second one. Therefore here I have 0 0 0 and then -4. Oh, okay, sorry, I forgot to add one row here, right? So but this is kind of echelon form. We need reduced echelon form. Echelon form, it means that all the leading entries should be 1. Therefore I can divide this one by -4 and then change it to 1, and then you shouldn't have also 0 here, 0 here. Therefore what I would do, so I just make this one, I want to just make this one and this one 0. Then what you have is 1 2 3 4, and then here 0 here. Okay, if you add this one, you have 0 0. Okay, now let's do that. So if you multiply this row by -2 and then add it to this, what you have is 0 0 1, and then 1, and then 0, and then 0. So and then if you multiply this third row by -4 and then add it to this, so here basically you have this 0 0 1 0, and now I want to multiply last row by -4 and then add it to here. Therefore what you have is 3, and then here you have basically you have basically 0, I guess. So we are, I guess, pretty close to pretty close to the reduced echelon form, but we know that in the echelon form, here is my leading entry, so above it and then under it should be 0. I can multiply the second row by -1 and add it to this and then make this one 0. Therefore, this gives you basically the reduced echelon form, and then you can easily get 6 points for that. So for the next part, you have to find the dimension for column space and dimension of row space. Okay, dimension of null space of A is basically the number of non-pivots, pivot column, and then dimension of column space of A is basically the number of pivot column. So okay, tell me which column is pivot. So here, this is pivot, right? This is pivot, and then this is pivot. Therefore, I have 3 pivot columns. Therefore, the answer is 3 here. And then I have 2 non-pivot. Therefore, the dimension of null space is equal to 2. Now, okay, what is A? A is basically the dimension of column space, and then B is equal to null space. Now, if you just replace A to be 3 and then B to be 2, you can check that this is equal to 0. So now, the next part is find the basis for the null space of A. So we know that. I want to just remind you, null space of A is equal to all x in R5, because we have 5 columns in R5 such that AX is equal to 0. Do you agree with that? Just remember, the size of this matrix A is 3 by 5, right? So therefore, we should just solve this system. When I want to solve this system, I should find the echelon form or reduced echelon form. Fortunately, we obtained this echelon form here. Then all you need to do, you should just encode this actually echelon form or reduced echelon form you have. To encode that, just write x1, x2, x2, x3, x4, and x5 here. Then from here, you can easily check that. I need a space here to write here, so you can easily check that. First of all, here is x5. So first of all, x4 is equal to 0. Okay, very nice. Then you can, if you encode now this, if you encode this one, encode means that this times this, this times this, this times this, this times this, this times this is equal to 0, because I want to find 0. So therefore, if I encode now, if I encode the second column, so what I have is x3 is equal to 0. And then if I encode the first column, I have x1 minus 2x2 is equal to 0. Therefore, this implies that x1 is equal to 2. Here is plus. Therefore, it's negative x2, right? Okay, therefore, what I have here, x1, x2, x3, x4, x5 is equal to, what was x1? x1 was negative 2x2. x2 was x2. Okay, write it as it is. x3 was 0. x4 also was 0, and then x5 it was free variable. Therefore, now I can just decompose it like this. Factor x2. Therefore, you have negative 2, 1, 0, 0, 1, and then plus x1, and then not x1, x5, then 0, 0, 0, 0, and then 1. And then you can, what is that? This is just a span of vector negative 2, 1, 0, 0. Okay, I think, okay, here, if you just factor x2, I think here I don't have a 1, so I just fix, I want to fix this one, so here must be 0, right? Sorry about that. So, and then, okay, therefore I have negative 2, 2, 1, 0, 0, and the other vector is this, 0, 0, 0, 0, and then 1. Okay, therefore null space is basically a span of these vectors. It's clear that those vectors are linearly independent, and therefore the correct format of the solution is basis, B means basis of null space of A is equal to the set of those vectors, set of negative 2, 1, 0, 0, 0, and this vector 0, 0, 0, 0, and then 1. So, and as you see here in the previous part, we obtained that the dimension of the null space is 2, and then here you can easily see that I have 2 vectors here, right? So, and this brings us to the end of question number 9. Let's go to the question number 4. Question number 4. Okay, the typical way that you can you can obtain the, okay, what is the question number 10? Question number 10 is a question, so you are given a 4x4 matrix, right? Sorry. And then you are asked for the first part, you are asked to find the determinant of A. Okay, to find the determinant of A, you can just expand the, for example, around the whichever column of rows that you have more 0, and then find the determinant of 3x3 matrices and find the determinant of 2x2 matrices, and then go ahead. But to be honest, for this matrix, I don't recommend that, because if you just do echelon form, not echelon form row operation, you can make this matrix kind of triangular matrix. And then when you have a triangular matrix, the determinant is just multiplication of the entries on the main diagonal. So namely, okay, let's make these elements here 0. If I want to make this element 0, therefore I have 1, 2, negative 1, 2. Here I have 0, 1, 1, 1. And then, okay, multiply row 1 by negative 2, add it to row 3. So therefore here I have 0. Therefore, okay, good. If I multiply by negative 2, add it to this, I have also 0. Then, okay, just want to see this 0, 0, 0, sorry. Here 0. Then multiply by, if you multiply by negative 2, 2 plus 1 is equal to 3. And then if you multiply this by negative 2 and then add it to this, you have 0. Okay, nice. And then here you have 0, 0, 3, 2. And as you see, by doing only one row operation, you got more 0 here. Look. So, and then you are about to find the kind of, to find the triangular matrix or lower or upper, doesn't matter. I don't want to memorize all the names, but it's just a matter of triangular having 0 like behind the diagonal or upper the diagonal, doesn't matter. So if you can make this part 0, then you are basically done, right? So let's make this one 0. So if you want to make this one 0, all you need to do, you should just multiply row 3 by negative 1 and add it to this. Therefore, what you have is basically 0 here, but this element will stay the same because here is 0. Therefore, you have this matrix. This matrix is a triangular matrix. Look at those nice zeros here that you constructed. So therefore, determinant of A is equal to just multiplication of 1 times 3 times 2 times 2, which is equal to 6. Therefore, the answer is 6. Now you are asked for to compute the this cofactor C14. So therefore, what you need to do is C14, which is equal to negative 1 to the power 1 plus 4, and then determinant of which matrix? Determinant of the matrix coming from what? Coming from omitting row 1. Okay, row 1 is here, and then fourth column. So determinant of this matrix: 1 0 1 1, and then 2 4 1, and then 0 0 3, right? So therefore, okay, this is going to be -1, therefore the answer is -1 times what? So to do that, you can just expand use the formula of determinant, expand around the last row, right? So therefore the answer is going to be -1 times okay, 3 times determinant, okay, 3 -1 to the power 3 plus 3, which is positive. I don't write it. Therefore, determinant of this matrix 0 to 0 1 2 4, which is equal to -3 times -2, which is equal to 6. Therefore, the answer of this part is equal to 6. Now, the last part, let B is the inverse of the matrix of the A. So, and then B is equal to Bij. Find B for 1. Should remember that A inverse is equal to 1 over determinant of A, adjoint of A. And also, you should keep in mind that adjoint 1 over determinant of A. Okay, what was the adjoint? Adjoint was basically Cij transpose. And in this question, you wanna, for example, in this question, this matrix, the entire of this matrix is called Bij, right? Bij. But because of this transpose, because you want to compute B for 1, therefore you should compute 1 over determinant of A, right? C1 for, right? In part 1, you already compute determinant of A, which was 6. C14 in part 2, you already computed is 6. Therefore, 1 over 6 times 6 is equal to 1, right? And then that's the final answer. As you see, this question is this example. From my perspective, I think it's not very difficult. My assessment about this exam is that, for example, I mean, you can just compute the determinant for many, of course. For example, here I just plug in the points and then find the solution, or here I found just by determinant easily this solution. Or this question, it was also determinant, also some conceptual things. This question is again determinant, and then this question is just about the inverse. So therefore, if you are among people who invested on how to compute the inverse of matrices, I think it was a good investment, because first of all, you have one question here was related to inverse, and you have also one question here which was related to inverse, 9 points here and I think 12 points there. Therefore, it was a pretty good deal to invest on these questions, because what was the question? Yeah, question number 6. Question number 6 and question number 10 which was basically related to A inverse and the formula. And then I think by knowing the fact that when you have a square matrix, then define and then if you obtain the determinant of this square matrix, this is not 0, this is equivalent to onto, this is equivalent to, if it is not 0, is onto, is equivalent to 1 to 1, is equivalent to linear independency of the columns. So I hope that this video is helpful. Thank you very much for watching this video, and don't worry about your score for this exam. Let's leave the past and then move on, and then think about the future and exam 2. Thank you very much.